Welcome back, everyone. In this lecture, we're going to show you how to work with the categorical data in our data set. So we just took care of the missing data. Now let's explore the categorical data and the string data and see if we either remove it or convert it to dummy variables using one-hot encoding. Let's head back to the Jupyter Notebook and continue where we left off. Okay, here I am at the notebook again. We've already taken care of all the null values. I can see here from before we have no more null values. So now what we need to do is take care of categorical variables. So the first task is to list all the columns that are currently non-numeric. And there's two helpful links here that essentially show you how to quickly get it through a very useful method call. And the way we can do that is if you checked out those links, it would tell you to run df select dtypes, and we could have selected pass in object as a single item string, and then call .columns, and that only selects the essentially string columns. So now what we have to do is we have to go through each of these, term, grade, subgrade, etc., and see what we should do with them. Some of them we'll just remove, others will be useful to us, and we'll keep them. So we have to decide, and the first one we're going to start off with is term. So let's go ahead and check out term, and if we check it out, term, in fact we can do a feature information request on term from that function that we have for you. It's the number of payments on the loan, and values are in months and can either be 36 months or 60 months. And if we take a look at df term and call value counts, notice it's essentially a binary column. There's either 36 months or 60 months, which means we have a couple of options here. Because it's also numeric, I could convert this to be either 36 as a numeric integer or 60 as a numeric integer. So directly just grab these basically first two numbers and convert them into an integer. The other thing I could do is, because it's technically just two categories, is I could one-hot encode it to be either 36 months or not 36 months. Now, because there is a numeric relationship between 36 and 60 months, let's go ahead and keep that numeric relationship, essentially showing you the relationship between having more time to pay off the loan. So what we're going to do is we'll map this directly to 36 and 60. And there's many ways you could do this. One way is to just create a dictionary called some mapping, and then map 36-month string to the numeric 36, 60-month string to the number 60. But another way we could do this is by grabbing those first two characters in the string and converting those into an actual number. So the way you would do that is by applying a function that does that, or a lambda expression. So what we're going to do is, to save a little bit of space, we'll do a lambda expression. We're essentially going to go through the terms, and for the terms, we'll grab the first two characters. So that's everything up to, but not including, index 3, and then we will convert that into an integer. And then we'll say df term is equal to df term, and we apply that. So we'll go ahead and run that. Keep in mind, you may get a warning, but in this case, that is okay. It's essentially warning you that you're taking an existing column and then reassigning it. So just telling you what you kind of already know. And if you take a look at df term now, you'll notice now it's just 36 and 60. So we can actually run this value counts again, and we see we essentially converted 36 months, 60 months to the integers 36 and 60. So that column has now been taken care of. It's now a numeric column that we can pass into TensorFlow. The next one we're going to take a look at is the grade feature. And we actually already know that grade is simply a part of subgrade. So we can just drop the grade feature, because recall that subgrade already had that information. If something was a subgrade G1, then we already knew it was part of the G grade. So that's essentially duplicate information, so we'll go ahead and drop it. Let's just say df is equal to df dot drop, and we'll say grade axis is equal to 1. Keep in mind, whenever you're running these drop method calls or function calls, you can only run them once, otherwise you get an error because you can't drop something more than once. So we go ahead and run that, and now we no longer have that column. And now what we're going to do is we're going to convert the subgrade column into dummy variables, and then we'll concatenate these new columns to the original data frame. A couple things to remember from the lectures is to drop the original subgrade column, since we won't need it after that, and to add drop underscore first is equal to true in your get dummies call to prevent the multivariable trap, essentially prevent encoding duplicate information. So let's go ahead and check this out. Lots of different ways you can do this, but there's essentially three main steps. The first step is to actually get the dummy variables. So we will say dummies is equal to pd dot get dummies, and then I'm going to obtain them from the subgrade column. So I have my subgrade column, and recall, since it's a column, I need to also say here that drop first is equal to true. And that eventually will stop us from encoding duplicate information. So that's why we dropped the first one. You can imagine in the case if we had some sort of gender or sex column where it was male or female, we don't need to encode both of them to be zeros and ones. Instead, that would just get converted to whether or not they're male, 0 or 1. Otherwise, you're duplicating the information. And that's the same thing if you start expanding to more categories. So if you have A, B, C as your categories, so if you have A, B, C, you don't need to encode that to 0, 1, 0 or something like that. You just need the A and B columns, because if it's not A and if it's not B, then it's implied that it's going to be C. So that's why we have drop first is equal to true there. Okay, so after that, we need to concatenate that with the actual data frame. So we're going to say df, and first we'll drop the original subgrade column, because we won't need it anymore since we have the dummies. And then what we'll do is concatenate that with the dummies. So we'll say pd concatenate this, we pass this as a list, concatenate it with, make sure that says axis equal to 1, with the dropping of the subgrade, and then say subgrade, actually just say dummies here, and then we'll say axes is equal to 1. So we do that function call, and then we set that to our existing data frame. So really just two main lines of code. First one is to get the dummies themselves off the subgrade column, and then the next one is to make sure to remove that original column and then concatenate it with the dummies along the columns. And that's essentially all there is to this. And you have to make sure that your brackets and parentheses match up. Looks like we're good here. So let's go ahead and run this. And there we go. So now if I take a look at df.columns, you'll notice I have a lot more columns because now we have one hot encoding for each of the possible subgrades. And we did drop the very first one, which was A1. Okay, so there are my columns now. And we're going to continue on. Let me go ahead and comment that out. And now we're going to essentially do the same thing for verification status, application type, initial list status, and the purpose column. So if you take a look at these other columns, they're also good candidates for being converted into dummy variables because there's not a whole lot of categories, and they're pretty much also, for the most of these, just binary or just a few categories. So they're good candidates to go ahead and just convert them into dummy variables. So we can actually do this with essentially the exact same steps we did up here. So I can simply just copy and paste these and then put them in here. And what I'm going to do is I just need to convert these columns. And we set them up in a way here that you can just copy and paste. So we're going to convert and get dummies. And with the get dummies command, you can pass in all of these guys at once. And then we'll go ahead and also drop the original columns at once. So we'll go ahead and do that as well. And that's pretty much it. So it's actually the exact same commands as before. You just pass in a list of the columns now, which is kind of nice. So no extra work we need to do. We'll go ahead and run that. That may take a little bit more time in case it was pretty fast here, but we went ahead and took care of those columns. Okay, now for home ownership, we'll go ahead and review the value counts here for the home ownership column to get something that looks like this. So we'll say df, home ownership, and if you do a value counts here, what you'll end up noticing is that essentially most people are in either three categories: mortgaging, renting, or owning. And then just very few are in other, none, or any. So what we're going to do here is, because there's so few people in none or any, let's just go ahead and put these guys, this 29 and 3, in the other category. So that way we reduce the number of actual feature columns, because we don't want an entire feature column for just 29 plus 3 people. Instead, we'll go ahead and put those in the other. So to begin this, we first want to replace none and any with other. And the replace link will actually show you this call, which allows you to directly replace string values with other string values. So we can see here there's documentation on how this actually works, but essentially the call looks like this. we say, and there's many ways you could do this. You could also just map it. You could say none and any get mapped to other, or just do your custom apply function. But the only thing I actually have to do here is called homeownership and say replace, and you can pass in a list of what you want to replace. So in this case, I want to replace none and any, and then you pass as a second parameter what you want to replace them with. In this case, I want to replace them with other. So you could do this either with a dictionary mapping, your custom apply function, or with this convenience replace function. Lots of different ways you could do this. So go ahead and run that replacement. So now if I run value counts again, notice those 29 plus 3 people have been added to the other column. So now we'll convert this into dummy variables. And to do that, I will simply copy and paste what we have before. So let me copy this guy. We'll come back down here to home ownership, paste that in, and replace subgrade with home ownership. So we'll put that guy in there and put that in there. Okay, so go ahead and run that. And now we've replaced home ownership. Keep in mind, you should only be able to run these one time, otherwise you'll start getting errors. Now the next column we're going to take a look at is the address column. So what we're going to do is, if we actually take a look at examples of the address column, it looks like it's somebody's full address. So it's some sort of address number, a street, a state, and then it looks like we also have zip codes. What we're going to be doing is we're going to be actually feature engineering by extracting the zip code from this. And there's many different ways you can do this. One way is to use the same technique we used up here when we were extracting the actual numbers from the 36 and 60 string. So notice that the zip code is always going to be the last 5 digits here. So we have these last 5 digits, which means if I were to apply a function or lambda expression, either one, if I said lambda, go ahead and take a look at that address and then grab, starting from position -5 all the way to the end, and run that, that will actually grab that last item of information. So if I take a look at this, I can say df zip code is equal to that extraction from the actual address column. So we run that, and now what we're going to do is take a look at making this zip code column into dummy variables. So we can essentially make a category per zip code. And if I did df zip code and then called value counts on it, you'll notice that there's actually not that many unique zip codes here. So we run this, and it looks like there's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zip codes. So that's not totally unreasonable to then create 10 dummy features off of this. Essentially 9 extra columns since we're going to drop the first one. So we'll just copy and paste the same code that we've been doing up here, but now we will replace home ownership with this new zip code column that we created. So go ahead and grab that, and then we're going to pass this in. Okay, we will run that, and then what we're going to do is we'll go ahead and drop that original address column since we won't be needing it anymore. So we'll say df is equal to df drop, and then we'll go ahead, pass an address there, along axes is equal to 1. Okay, so that took care of the address column. Next one is issue underscore D. So if we take a look at the feature information for this guy and run it, you'll notice that this feature information indicates the month which the loan was funded. And if we actually think about the problem we're trying to solve here, is we're trying to specify, based off someone's already known features, whether or not they're going to pay back a loan, which ideally, that's going to happen before we actually issue them a loan. Because if we think they're not going to actually pay back the loan, we won't issue one in the first place. So we, in reality, won't have an issue date for when we're actually running the model. It's not like we're already going to know that we issued them a loan. Otherwise, that kind of defeats the whole purpose of the model. So this is actually data leakage, since realistically speaking, upon application of the model, you won't have an issue date. So we'll go ahead and just drop this column. We'll say df is equal to df drop, issue date, along axis is equal to 1. Okay, next one is this earliest credit line. So if we take a look at this function or this feature closely, in fact, we can just call feature information here and pass in earliest credit line. this appears to be the month the borrower's earliest reported credit line was open. So this is a historical timestamp feature. So what we're going to do is we're going to extract the year from this feature using a .apply function. So there's lots of different ways you can do this, but we're first going to convert it to some sort of date feature, or we can actually just grab it based off its position. So let's take a look at the examples in this actual column. We'll say earliest credit line, run that, and notice right now it's essentially 3 letters for a month, a dash, and then the year of the earliest credit line. So what we'll do here is we can either convert this to a date time and then extract with an attribute call the year, or just grab the last 4 characters in the string and convert that to an integer. That's probably slightly easier to do, so we'll go ahead and do that approach, although either one is totally valid. So we're going to say apply lambda, and on this date, go ahead and starting from position -4, go all the way to the end to grab those last 4 characters, and then we will convert that to an integer. And we'll say df earliest credit line is now equal to this. So we'll go ahead and run that, and we'll say df earliest credit line, and now if we take a look at it, we have this new column. Now keep in mind, if you follow these task instructions exactly, we did ask you to create a new column called earliest credit year and then drop the earliest credit line feature. It's essentially the same thing if you just overwrite it. So you can overwrite it or assign it to some new column and then drop it. Really up to you. Main idea here is that we essentially just want the year, since that's something we can work with. And in fact, we can further explore this by doing value counts on it. And note here that we have value counts that make sense. And we don't need to convert this to dummy variables because the year itself can be treated as a continuous data type. Okay, so moving along, the next series of steps will just be pre-processing, things like train test splits, as well as scaling the data. So we'll go ahead and take care of that in the next lecture. I'll see you there.